this out of the way. What if there's a case where there are two things on the bottom? So for example 5, let's say it's a log, and again if I don't write a base it's assumed to be 10. Let's say it's x squared over 3y to the third. Okay, so the question is, since there's a times here, where does that go? Okay, so I know it's log x squared. I know the 3 is a minus, so it's going to be minus log 3. Okay, but the y cubed, is it a plus or minus? It turns out because it's on the bottom, it's a division, so it's going to be a minus log y cubed. Okay, and then bring the exponents down, so the final answer, 2 log x minus log 3 minus 3 log y. Okay, the next thing they're going to ask you to do, instead of expanding it, okay, is they're actually going to ask you to condense, meaning we're going to use the properties to put the logs together. Okay, so in our next examples, let's condense. Okay, so this would just be a case where you have something like this. 2 log base 3 of x plus 3 log base 3 of 4. Okay, so we're going to go backwards. So what I'm going to do is actually I'm going to take the numbers in front and move them back up as exponents. Okay, so let me do that again. So we're going to take the numbers in the front and we're going to move them back up as exponents. Okay, so the new problem looks like this. Log base 3 of x squared plus log base 3 of 4 cubed. Okay, and then plus turns into a times. So there's one log only one log, and it's going to go x squared times 4 cubed. 4 cubed, you can work that out to be 64. Okay, let's try one more problem, and then we'll use the other properties. Let's add 1/2 log x plus log y plus 3 log z. Okay, so again, first step, I'm going to take any numbers I see and move them up, move them as exponents. Okay, so the new problem becomes log x to the half, again we're assuming base 10, plus log y plus log z cubed. Okay, so this becomes one log. Since they're all plus, it's going to be multiplication all the way. X to the half is really radical x. The y is just by itself, and then z cubed is by itself. That would be your final answer. Okay, let's throw in a minus. So let's say it's, let's use ln. ln of x minus 3 ln of y minus 2 ln of 2. Okay, so again, first things first, I'm going to take my numbers, move them up as exponents. Take my numbers, move them up as exponents. So this becomes ln x minus ln y cubed minus ln 2 squared. Okay, so I see minuses, so that tells me there's going to be a fraction. You just have to decide what goes on the top and bottom. It turns out that since x is a plus, it's going to go on top. And since y cubed is a minus, it's going to go on the bottom. And since 2 squared is a minus, it's going to go on the bottom. So 2 squared, again, if you want to simplify, would actually be equal to 4. Okay, since there's time, I'm actually going to cover very quickly 45 through 50. So this thing has to do with what's called, change of base formula. Okay, so change of base. If you look at the calculator button for logs, the calculator button, I'll put it up here in a second. It's not easy to see, but the calculator button for log right here has no space for a base. So in other words, you can't really change the base, and you're stuck actually with base 10. Okay, so change of base is going to be helpful in that case. It says the following: log base b of any number m, even though if it's not base 10, here's what we can do. We can pretend it's base 10, and then divide by log of the actual base. Okay, that's kind of confusing, so we'll do 2 examples. So for example, if I wanted to calculate log base 3 of 2, on your calculator you would punch in log of 2, so pretend it's base 10 if I don't write anything, over log of the actual base, which is 3. Okay, plug that in the calculator, you'll get some number. Similarly, if I had log base 4 of 7, that would be log of 7, so pretend it's base 10, over log of 4.